Okay, so we should have these 4 done by now, for sure. 1, evaluate 2n minus 6 if we know n is equal to 4. So what should we do if we know n is equal to 4? What's the fancy word we use? Substitution. Or plug in. Right? That'd be the Sand Mountain word. Plug in the 4. So this would be 2 times 4 minus 6, which is 8 minus 6, which simplifies to be 2. Questions on number 1? Number 2, evaluate f of 4 for f of n is equal to 2n minus 6. Well, if I've got the whole function rule, I'm going to plug in 4 for n to find f of 4. So f of 4 would be 2 times 4 minus 6. So f of 4 would be equal to 8 minus 6. So f of 4 is equal to 2. So what do we notice about 1 and 2? They're almost the same thing, right? They're different ways to write down very similar problems. One thing I want you guys to notice, that I've not looked at you guys how you work out math yet. Hopefully you've got a good system in place, and I'm not going to have to change a lot, but that's not normally the case for Algebra 1 students. You are normally random and all over the page, right? Which is not ideal. Here's the things I want us to notice for 1 and 2. Number 1, does anybody know what this is called? 2n minus 6?
Equation.
It's not an equation. It's the other one. It's an expression. So an expression is a math statement without an equal sign. Let's say it again. Expression is a math statement without an equal sign. Notice in all of my work, did you see me put an equal sign anywhere? No. Do you have an equal sign on your paper for an expression? You shouldn't. An expression is a math statement without an equal sign. So don't add an equal sign. Do we see that? See how that flows? Another thing that I've not looked at your paper, but I bet there's somebody in here that's done this. Say you did all the work I did, but you did it like this. 2 times 4 minus 6, and you said it equals 8 minus 6, and it equals 2. Well, that's bad. Okay? We don't want to go sideways, so we need to get out of that. And we don't need multiple equal signs on one line. That's bad. Okay, so these are some things that you're going to have to get out of the habit of, because as we get problems that are more difficult, you can't be working sideways, multiple equal signs, or you're going to get confused. You know how I know that? Because I did it. Okay, I was the least organized notes-based person I know. I didn't write notes. My papers were sloppy. I always told all my teachers the lines were optional. Go down lines. I would work sideways. I ignored the lines completely. You know what my teachers thought of me? Probably not much. But now look at me now. Anyways. 2. Look how 2. I worked down the page again. You see that? What's the difference here? This is
That's an equation.
It's an equation. It's a math statement with an equal sign. So guess what? I keep that equal sign in line the whole way down the page, simplifying the right side. So notice how on the right side, all this work looks the same as this work. Right side of an equation, that's where I do all my work. The left side It's just my function rule. It's basically a placeholder. It goes down the page. Everybody's good there? 3, evaluate z squared if z is -6. So what am I going to do? I'm going to substitute -6 into z. What would that look like? -6 squared. What is -6 squared?
36.
What kind of math statement is this?
This is an expression.
Expression. No equal sign. So what's my paper look like? No equal signs. All right, we follow? Number 4. Now I'm evaluating f of -6. If f of z equals z squared. What do I have this time? And
Equals.
so that's an equation. So every line I'm going to have an equal sign. So I'm going to be finding f of -6, which is equal to, this one's a little bit of a trick, -6 squared. What is -6 squared? Should be positive 36. Anybody get -36? Nobody? I'm not buying that.
I didn't get that.
Thank you. Okay. This one's tricky because I'm plugging -6 in for z. So on your calculator, you have to make sure you write it like this with the parentheses. If you put this in your calculator, it's going to give you -36 as the answer. So you have to make sure you have it in parentheses. Okay, what about 5 and 6? What kind of math statement are we looking at on 5?
Expression.
Expression, no equal sign. What am I plugging in?
-2.
-2 for x. That gives me 3 times -2 squared minus 1. Order of operations. What do I do first? Parentheses. Is there anything to simplify in parentheses? No. What's next? Exponent. Do I have an exponent? Simplify it. -2 squared is 4. What's next according to the order of operations? Well, yeah. I like that better. We do parentheses, we do exponents. Next we do multiplication and or division at the same time. Left to right. We go left to right. So whichever one we see first, from left to right. You guys knew that, right? Yeah. So do I have any multiplication or division?
No multiplication. 3 times 4.
3 times 4 is 12. And then what's next?
Addition and subtraction at either or.
That's right. Addition or subtraction at the same time. From left to right. There's 4 steps to the order of operations. That's the way I write PEMDAS. That shows me each step in the correct order. And so now I need to add or subtract. 12 minus 1 is
11.
13. Yep. Next, 6. Evaluate f of -2. I wonder what this is going to look like. This time it's an equation. Math statement with an equal sign. So when I work it out, I'm going to have an equal sign. It's the same process. Simplify. Parentheses. Nothing to simplify. Exponent. -2 squared is 4. Multiply and divide from left to right. Add and subtract from left to right. So I would get f of -2 is equal to 11. sometimes on these equations, when you have a lot of steps, notice how on the third step I didn't write down the left side of my equation? Because I knew it was the same thing. I just saved myself a little bit of time. The left side of the equal sign stayed the same, but I kept that equal sign in line. Follow? Good practice.